So next topic of the module 1 is diagonal matrix or reduces to diagonal matrix form or diagonalization. Diagonalize the following given matrix. Sometimes they may ask question, diagonalize the following matrix or reduce the given matrix into diagonalization form. So in this concept, first before going to diagonal matrix, we want to learn about similar matrix. Two matrices are two square matrix, same order, are said to be similar matrices if there exists a non-singular matrix. That means whose det not equal to invertible matrix P such that B equal to P inverse AP. Then A comma B are said to be similar matrix. B is said to similar. B is said to similar to A means there exists a non-singular matrix P such that B equal to P inverse AP. Then A is said to be B is said to be similar to A. Now in case of diagonalized matrix, a matrix A is said to be diagonalizable if there exists a diagonal matrix. In place of B, we exist a diagonal matrix. Only diagonal elements are there, other elements are zeros. In place of B, we have a diagonal matrix. Same thing. Diagonalization, nothing but a similarity. In place of B, we have a diagonal matrix. If the similar matrix B of the matrix A is a diagonal matrix, then the matrix A is called diagonalizable. That's all. So procedure, how to find the diagonalization process. First find the eigenvalues and corresponding eigenvectors. Eigenvectors are taken in the column forms. We get a P matrix. This P is existed by taking eigenvectors in a columns. Okay, this is the procedure. So important concept. This is also this diagonalization process is useful to find powers of a matrix. Given matrix A, find A power 10, A power 100. That time it is very helpful to us with no need to find out A power 100, A power 200, 100 times computations. By using diagonalization process, we reduce the number of computations. So here I am going to discuss these two problems. First problem is reduce the matrix to diagonal form. So first problem, reduce means as per procedure, first find the eigenvalues, then eigenvectors, take eigenvectors into column form, we get a matrix P. This is the problem. Every time I'm using reading pen. Okay, it is comfortable to visibility. So this is A. First diagonalizable means first find the diagonalize the or diagonalization form, diagonal form or diagonalization form. So find eigenvalues. So I give these two problems for you. I want to pick a previous problem. Already we have eigenvalues and eigenvectors. So from the previous topic, I'm going to pick okay. Already just previous process, we find the eigenvalues, eigenvectors of the 2 by 2 matrix. Already we know the eigenvalues, eigenvectors of the 2 by 2 matrix. Now here I am going to take this part, including eigenvalues and eigenvectors. Okay. Easy to diagonalize. Yes. Up to this, here I am taking coffee. Now in our document, we paste it, and in place of this problem, I am going to prove this problem. Actually, here in place of find eigenvalues, eigenvectors, reduce the matrix into diagonalization form or diagonalizable form into or to. to diagonal form. Some people diagonalization form call it as. So first step is, whenever they ask this kind of problems, first step is find eigenvalues and eigenvectors. Whenever you see the diagonalization problem, it is too complex because first step is we find eigenvalues, then eigenvectors. These two are must whenever we want to show the diagonalization form. So diagonalize the form. This is first find eigenvalues. We get two eigenvalues, corresponding eigenvectors. Now, after finding corresponding eigenvector, you say first matrix has x1, second matrix x2. Therefore, after finding this, already we saw this, how to find the eigenvalues, eigenvectors. Therefore, matrix P equal to x1, x2. x1 means first eigenvector corresponding to lambda equal to 1. Lambda equal to 1 eigenvectors are 1 comma minus 1. 1 comma minus 1. Enter the eigenvectors 1 minus 1. This is x1. x2 means eigenvectors corresponding to eigenvalue lambda equal to 6. This gives the P. Now find P inverse. Now P inverse. P inverse equal to 1 by AD 1 into 1 minus 4 into minus 1 times of interchange the diagonal elements, take minus sign with the off diagonal matrix. This gives inverse of the matrix. You know the definition. Plus 4 plus 1, 1 by 5. 1 minus 4, 1, 1. This gives P inverse 1 by 5 minus 4 by 5, 1 by 5, 1 by 5. Now that's all. So P inverse okay, but our intention is to show the diagonal expression. Now P inverse AP, find this value. This resultant value equal to diagonal matrix, then we say that A is diagonalizable. P inverse is 1 by 5 minus 4 by 5, 1 by 5, 1 by 5. What about A matrix? The given A matrix is 5, 4, 1, 6, 1, 2, 5, 4, 1, 2. 5, 4 be the first row elements, 1, 2 be the next row elements. P is 1 minus 4, 1, 1. Now multiply these three matrices. Finally, we want to show that the resultant matrix is diagonal. You multiply any two because either last two or first two, because matrix multiplication satisfies the associative property. So you take multiplication either for the first two, then with the last one, or first you do the multiplication by using last two, then pre-multiply with the first one. So now here I am taking 5 plus 4, 9. Directly I am taking because our intention is not multiplication process. Minus 20 plus 4. Minus 20 plus 4. How much? Minus 20 plus 4 equal to minus 16. Here 1 plus 2, 3. Here minus 4 plus 2, minus 2. Now what about resultant matrix? 9 by 5 minus 12 by 5. First diagonal element is, second diagonal element is minus 16 by 5 plus 8 by 5. Is it okay? Somewhere missing. We'll see. Same 1. Here I enter wrongly. P inverse, interchange the matrix minus 1 plus 1. 1, 1, interchange minus 4 minus 1, okay. 1 by 5. Here I enter P value is minus 1. I make a small change. Here above plus 4. P matrix I enter wrongly. Here minus 1. Now multiply the matrix, we get 5, 4, 1. 20 plus 4, 24. 1 minus 2 minus 1, 4 plus 2, 6. Now the resultant multiplication, which is equal to 1 by 5 plus 4 by 5 Next 24 by 5 plus 24 by 5. 1 by 5 minus 1 by 5. 24 by 5 plus row by column 6 by 5. Anyhow, some mistake is arised. Okay, no mistake, because off diagonal must be zeros. Here 5 by 5, 1. Here 0. Here 0. Here 24 plus 6, 30 by 5. 35 by 6 means 6. So it is diagonal matrix. Only diagonal elements are there. In the diagonal also eigenvalues only there. 1, comma 6 are the eigenvalues. You keep in your mind always we get eigenvalues. So diagonalizable. Therefore, A is diagonalizable. Okay, this is the procedure to find the diagonalization. For this one only, I am going to find a power 5 value. Find a power 5. A power 5 using diagonalization process. So A, already we know A inverse equal to, D diagonalization equal to P inverse AP, and you know previously we take a P inverse AP, we get D. Now we want to A power 5. So take D power 5 or D square. First you observe that it is better. D square. What happened? No need to write down this process in the examination point of view. For understanding purpose, I am writing. Finally, we realize that it equal to P inverse AP into P inverse AP. P inverse identity matrix. Finally, we get P inverse A into A square. A square P. D square nothing but P inverse A square P. Similarly, you can expand any n, D power n equal to P inverse A power n P for all n equal to either 1, 2, 3 and so on. If D equal to this one, so D equal to 1, we get the given equation. D square means this. D cube means here we get 3. So now we want to D5. No need to write down in the examination point of view. D5 equal to P inverse A power 5 into P, because we want to A power 5. So keep A power 5 in the right hand side. Other move to left hand side by matrix multiplication. Pre-multiply with the P. Post multiply with the P inverse. Now we get P D power 5, P inverse equal to A power 5. I am writing A power 5 equal to P D power 5 P inverse. P means eigenvector matrix. Eigenvectors are 1, minus 1, 1, minus 1, 4, 1. 1, minus 1, 4, 1. D power 5 means diagonal matrix is this one. We got the diagonal matrix, this one. Whole power 5. P inverse, we got 1 by 5 times of 1 by 5. Here minus 4 by 5. Here 1 by 5. Actually, in case of diagonal matrix exponent, we have this only affect the diagonal entries. Other entries are 0. So A power 5 value nothing but 1, 4, minus 1, 1 into 1 power 5, 0, 0. Only diagonal entries are affected by the exponent. Same exponent we get. Okay. It is easy to multiply. Previously, we have more multiplication. Now we reduce the matrix multiplication of 3 by 3 matrix, 3 matrices. Here 1, 0, 0. What about 6 power 5? 6 power 5 in 6 power 5 means 36 into 6. Okay, it is better to keep a 6 power 5. Later we will see if it is necessary. We can simplify. Okay, as your wish. You multiply from left to right or right to left. It is a diagonal matrix. Then multiply pre-multiplication. We get 1. Here now I am using first two multiplications. Then 4 into 6 power 5. First row element. Second row element is minus 1. 6 power 5. Next matrix 1 by 5 minus 4 by 5. 1 by 5. 1 by 5. Now what is the row by column multiplication? You evaluate it. We get the a power 5 value. 1 by 5 plus 4 into 6 power 5 by 5. So minus 4 by 5 plus 4 into 6 power 5 by 5 minus 1 by 5 plus 6 power 5 by 5 plus 4 by 5 plus 6 power 5 by 5. That's all. Simplify this expression, we get the value. This is a power 5. This is the procedure to find a diagonalization process. Whether the given matrix is diagonalizable or not, sometimes they may ask. Most of the time, reduce the following matrix into diagonal. Here I leave the our selected problems, but I take from the previous problem only. Do it. These two are do it yourself. Okay. This is the procedure to find a diagonalization process.